IOE 413, Mathematical Preliminaries Study Guide. This question asks you to write down the necessary and sufficient conditions for optimality to this linear program. The three conditions that are necessary and sufficient for a solution to be optimal to a linear program are primal feasibility, dual feasibility, and strong law of duality. Primal feasibility is nothing more, in this case, than ax equals b, and x is non-negative. The second is dual feasibility. And to write down the dual feasibility, we need to go to our primal dual grid. In order to make the dual feasibility requirement, we need to consult this table. And let's just remind ourselves what the primal is. I'll write it over to the left-hand side here. It's minimize C transpose X such that AX equals B and X is non-negative. This is a minimization problem. Our sign restriction on x is greater than or equal to 0, so let's come down the column to the sign restriction being greater than or equal to 0. Go over to the left, and we see that our dual constraints will have a less than or equal to sign. So we can write down our dual constraints as pi transpose A is less than or equal to C transpose. The other thing we need to check are the sign restrictions on the dual variables. And that's driven by what we have here in our primal constraints, an equality. So let's come down our column here to equality, follow over the left-hand side. What we have here are that the dual variables are unconstrained. So that means that the dual variables are just in Rn. There's no sign restriction whatsoever. Because there's no sign restriction, we don't need to write anything down. So in fact, our dual feasibility requirement is just pi transpose A is less than or equal to C. So the dual feasibility constraint that needs to be satisfied is pi transpose A is less than or equal to C transpose. And then finally, the strong law of duality says that C transpose X is equal to pi transpose B. Those are the equations that are necessary and sufficient when taken as a group to define the set of optimal solutions to the linear program we started with.